Welcome. This is Odum Maths. Please don't forget to subscribe, like, and share this channel. Okay, please, today I want us to look at right-angled triangle. Right-angled triangle. Okay, and that trigonometry. Okay, now, what's a right-angled triangle? So, the only thing that depicts an angle or a triangle to be a right-angled triangle is the 90 degrees symbol. Since this contains the 90 degrees, then it means this is a right-angled triangle. Okay. Now, let's consider the sides, the names of the sides. This side has been called, according to this diagram, A. Then this has been B. And then this side, the longest side, becomes C. Okay. Now, per this, the longest side is always the hypotenuse side. Hypotenuse side. Then, considering the angle that we are making reference to, this can either be opposites or this can be opposites. And this can be adjacent and this can be adjacent. Okay. The longest side is the hypotenuse and then the rest. Okay. Now, let me also call this points. Let me call here A, B, and then C. Okay, so we can make reference to line AB, line BC, and that of line AC. Okay, now let's talk about the trig ratios. Okay, so they are mainly sine, cosine, and then tangents. Tangents. Okay, so the short form of this is the sine, S-I-N. The short form of this one is also cos. Then the short form of this is tan. Okay, so as we move along, I'll be using the sine, cos, tan. Okay, to mean that this is the sine, this is the cosine, and this is the tangents. Okay. Now let's consider the angles in the right angle triangle. So if this is 90, then it means when we add the two, we should be getting 90 degrees. So this and this gives us 90, plus the 90 will give us 180 degrees. Okay, now let's look at this mnemonic. We have something we call SOHCAHTOA. Okay, so the SO here means that the sine, which is equal to opposites over hypotenuse. The C here, the K, means the cos, which is equal to adjacent over hypotenuse. Then the T tan, which is equal to opposites over adjacent. Okay, so now let's look at this right angle triangle. Let me write it here. So my sine per this angle, so sine theta, is equal to, this angle faces this side. So theta faces the side A or side AB. So that is equal to A over hypotenuse, which is C. Then cos theta also that is adjacent. So this side is adjacent to the angle theta. So that is adjacent, which is B over hypotenuse C. Then the last one, tan theta, which is equal to opposite over adjacent. So opposite over adjacent. So that is A over B. Okay. So when you talk of the reciprocal ratios, that is, sine is going to give us the cosec, that is 1 over sine. Then that of course is secant, which is 1 over cos, and that of tan is cot or cot, which is 1 over tan. So we'll talk about that as we move on. Okay, now let's talk about that of alpha, the angle alpha. Okay, so for alpha, I am going to start from sine. So let me continue with this. So sine alpha is equal to, please, alpha faces B. So B is opposite to alpha. So sine alpha is opposite, which is B over hypotenuse C. Then cos alpha is also, this is the adjacent side of this angle cos, alpha. So that is going to be A over C. So that is adjacent to hypotenuse. Then tan alpha is also, tan is opposite over adjacent. So opposite over adjacent. So that is B over A. Okay. Please, we can make some comparisons here. We can note and see that sine alpha is equal to cos theta. So sine alpha is equal to cos theta. Then cos alpha is equal to sine theta. So sine theta is A over C. Sine cos alpha is also A over C. Then for tan theta and then tan alpha, they are reciprocating. So this one is A over B and this is also B over A. Okay. Now let's look at an example on this. How a question, if a question is given, how we are going to approach the question. Okay. So now let's look at this example. If theta is an acute angle and cos theta is equal to 3 over 4, find the values of trig ratios or trigonometric ratios of theta. Okay, so when such a question is given, the best thing for you is to draw the diagram, the right angle triangle. Okay, so let me draw my right angle triangle. Okay, now let me put theta here. Now we are told that cos theta is equal to 3 over 4 and cos is adjacent over hypotenuse. So 3 over 4 because it is adjacent over hypotenuse. Okay, now we need to find the side here. Let me call the side x. Okay, now we are going by the Pythagoras theorem, which says that the sum of the squares of the other two sides sum up to the square of the hypotenuse, or the square of the hypotenuse is equal to the sum of squares of the other two sides. Okay, so this is going to give me 4 squared equals 3 squared plus x squared, and this is 16 equals 9, so that is 3 squared plus x squared. So this place becomes x squared becomes 16 minus 9, and then x squared is going to be 7. Okay, now to remove this, you need to put square roots on both sides. So square roots here, square roots this place. So x becomes root 7 or square root of 7. So this place is square roots of 7. Okay, now we are told to find the other trig ratios. Okay, and other trig ratios we know of sine. Okay, now sine is equal to opposite over hypotenuse. So this angle is opposite to the side. Then this is the hypotenuse. So that is going to be root 7 over 4. Then cos has given already, so we need tan. So this is sine theta. So we need tan theta. Opposite over adjacent. So root 7 over adjacent. That is 3. Okay. Okay, let's look at one more example. So if tan x is equal to 1 over 3, find cos x minus sine x such that 0 degrees less or equal to x less or equal to 90 degrees. Okay, so I said when a question of this nature is given, the best thing is to draw the diagram. Okay, now let's draw the diagram. So let me draw this diagram. Right angle triangle. Now tan is, let me put the angle here. X, the angle is x. So let me put x here. So tan is opposite over adjacent. So opposite to this angle is this side, 1. Then adjacent is this side. So that is 3. So we need to find this side. So let me call it here A. Now we can say that A squared per Pythagoras theorem. A squared is equal to 3 squared plus 1 squared. So A squared becomes 9 plus 1. And then A squared becomes 10. So we put square roots on both sides, and then A is going to be root 10. In this sense, my sine x becomes sinus. So that is opposite over hypotenuse. So that is 1 over root 10, because we had root 10. Then cos x is also cos is adjacent over hypotenuse. That is 3 over root 10. Okay. So now cos x minus sine x is going to give us 3 over root 10 minus 1 over root 10, and which we can say that this is going to be 3 minus 1 all over root 10, and that becomes 2 over root 10. Okay. Please don't forget to subscribe, like and share this channel. Thanks for watching. The name has always been Odum Maths. Bye.